video, we're going to look at how we can subtract vectors. Subtracting vectors is very similar to adding vectors that we did on the previous video, and you can practice this in IXL U.8. So let's look at this drawing here to help us understand what it means to subtract vectors. When we subtract vectors, you could say A minus B is the exact same thing as actually finding A plus negative B. And you can see that I've demonstrated that right here. So when we are subtracting, it's the same as thinking of adding the opposite of the second one, right? So what would that look like visually? Well, visually, you can see my drawing over here. We have A and B. This would be our original vectors, okay? A and B in red and yellow. But then I have drawn negative B. What is negative B? Negative B would be the opposite vector. So for our regular B vector, if you notice, we go over 3, so we have a horizontal change of 3 and down 4. So we have a horizontal change of positive 3 and a vertical change of negative 4. So our negative B would be the exact opposite. It would have a horizontal change of negative 3 and a vertical change of positive 4. That would be the opposite vector. So visually, if we want to think about how we subtract vectors, you would need to draw the opposite of whichever one you're subtracting. So you would need to draw the negative vector for the one that you're subtracting. So here, the B, and then you would need to use whatever method you could to graph it. So in this case, we have the initial points lining up. So because of that, we would use the parallelogram method. If you had terminal ends lining up, then the terminal lining up with an initial point, then we could use the triangle method if we're thinking about this graphically. If we're thinking about how to solve this numerically, then it's going to be pretty simple, like when we're adding them, right? So if I have vector, let's just say my first vector here is 3, 4, and let's say I have another vector x, we'll call that vector x, and it has a horizontal change of -2 and a vertical change of 3, we'll say, okay? Then if I want to find v minus x, then there's two ways I can think about this. I could think about simply subtracting the components, so doing 3 minus -2 for my horizontal component, or 4 minus 3 for my vertical component. Or, again, I could think of it as v plus -x, which would just be, as a side note here, -x would equal the opposite of whatever it is, so +2, -3. So we could think of adding this vector that's the opposite to the original one, whichever way it's easier for you to think about. So as I'm solving this, v minus x is going to equal, well, if I think of it as subtraction, then 3 minus -2 is the same as 3 plus 2, so it would be 5, and 4 minus 3 is 1. So that's it. I'm done. So let's go ahead and look at IXL real quick here. So if we go to, let's go there real quick. So if we go to U.8, subtract vectors, similar to with addition, I think it's going to show us the graph first. Yep, there we go. So we can piece it apart from there. So there's a couple things you guys could think of here. So first of all, if we want to do this graphically, let's think about the fact that we're doing y minus z is the same as y plus -z. So what would -z look like? It's going to be the opposite, okay? So right now, z has a horizontal change of 1, 2, 3, 4, -4, and vertical change of 1. So instead, we're going to have a horizontal change of +4, 1, 2, 3, 4, and a vertical change of -1. and we would have our vector right there. Or here, I'll try to put it in red. That would be negative z, okay? So we have a terminal in lining up with an initial point. So that means I could go ahead and use the triangle method to solve. So with the triangle method now, I would need to convert this into component form to get my answer. So I need to look and ask myself from my initial point, what is my vertical and horizontal change? Well, I know it's getting a little messy here, so I'll go ahead and erase these parts so we can kind of see what we're doing here. Okay, so my horizontal change is positive 1 from my initial point, so I'm just going to put 1 there. And my vertical change is 1, 2, 3, 4, 5. My vertical change then is negative 5. All right, and for this one, we could do the same thing, but I also want to make sure you guys know you can see how to do it numerically. So for this one, instead, let's do it the other way. Let's label what component-wise what these two vectors are. So x component-wise has a horizontal change of negative 6 and a vertical change of positive 2. And again, the way that we find what that component-wise is we're looking at the change from its initial point. So just start at its initial point. So this is x's initial point. And I count what is my horizontal change. Well, it has to go over negative 6 and my vertical change up 2 to get to my terminal point. And let's do the same thing for y. So now I start at my initial point, and my horizontal change is positive 1, because it goes to the right 1. And then it goes up 1, 2, 3, 4, 5, 6. Positive 6. So if I want to do x minus y, then I am subtracting these values. So negative 6 minus 1 would be negative 7, and 2 minus 6 would be negative 4. So it would be 7, negative 7, negative 4. There we go. So the rest of the problems are going to be similar to that. Just use that information and you should have everything you need to solve these problems.